Hey guys, welcome back. So now we are going to actually look at some free response questions for inference for two population proportions. Again, these are really in-depth. These are really long, beefy problems. Sorry, just get used to writing and write small. This first one in particular is going to be really big because I'm going to show you both ways, looking at confidence intervals as well as looking at a significance test, and we'll try and compare the results that we get. And then also we are going to do one more example together. There are two more FRQs on this document that I want you to try and do on your own and submit them to me so that way I can check your work and see how you're doing. All right, so let's go ahead and get started. Again, I might pause and kind of like go through some of the writing a lot faster just so you don't have to watch a blank screen of me writing. So I'm going to speed up the video in certain places just so you know. All right, let's get to it. This first one, are teenagers going deaf? In a study of 3,000 randomly selected teenagers from 88 to 1994, 450 showed some signs of hearing loss. In a similar study of 1,800 randomly selected teens in 2005 to 2006, 351 showed some hearing loss. So very, very brief as far as what is going into this prompt, but you should be able to recognize some of the key phrasing, two different random selections, two different groups of people. So two different samples, two different populations, also two different numbers of successes. And we're going to want to write that stuff down. Now, for part A, do these data give convincing evidence that the proportion of all teens with hearing loss has increased? Okay? Convincing evidence to me usually says do a hypothesis test. So that's what I'm going to do for part A. Okay? And I want to start by writing out all of my given information. It just keeps me organized. And I'm going to use different subscripts. I'm going to start off with this. N sub 88, that's going to be my sample size from the years 1988 to 1994, and that was a total of 3,000 people. And then that makes me think about, well, how many people are in that population? Well, it's all teens from 88 to 94, so we know that's going to be a big number, right? So we know that's going to be true. And then we are going to say, well, what's this 450 number? Well, that's the number of teens that had some hearing loss. So that's going to be our number of successes, right? So X sub 88 is 450, and that's our successes. Okay, and then if we want to, we can also write out a p hat, and that would be written out as 450 out of the 3,000. They are the ones that actually had some signs of hearing loss. So I need to make sure I provide that subscript as well. Okay, so the next thing I'm going to do is actually write out the same thing, but I'm going to do it for the other population I have, and you'll see the subscript that I use and how it makes sense. All right, so now that we've got all of our given information out, let's go ahead and write out our null and alternate hypothesis. So my null hypothesis is simply that the two proportions are going to be equal to each other. And again, I'm using these subscripts instead of P1 and P2 just to help keep me a little bit more organized. So P sub 88 equals P sub 05. And then my alternate, we have to be really careful about this, and you have to pay attention to the keywords. It's saying that the proportion of teens with hearing loss has increased. So what we think about is, well, here was the proportion of those in 88, and then the proportion in 05 and 06 at a later date and time is greater than, it's increased. So that means we actually have to look at it in this way, that the P of 05 is going to be greater than that of P of 88. Well, what are P88 and P of 05? This is where, again, it is essential that we actually define these parameters. So we have to write this out, where P sub 88 and P sub 05 are the proportions of teens with hearing loss from 1988 to 1994 and 2005 to 2006 respectively. And we use that word respectively because it's showing that the order in which we wrote them out actually matters. Okay? Then we can actually decide what our significance level is going to be. We'll go ahead and let alpha equal 0.05, and then before we actually conduct our test, we know we have to check our conditions. So let's go ahead and check our conditions for the first one we have, random sampling. Did we have a random sample from both? And we say yes, we did. So we had random sample from both. Then we also had the 10% condition was going to be satisfied because we know we're looking at all teens from both groups. So we would say that 3,000 is going to be less than 1/10 of n of 88. And also we have the other sample size was 1,800, and that's less than 10% of the population from 05. So that's checked and that's checked. And then finally we have our LCC. The LCC is the one that can get to be a little bit of a pain, but again, we know it's number of successes. Let's look at the 88 group first. That was 450. That's our number of successes. How many teens said they had hearing loss? We know that's greater than 10. And also we look at the number of failures. Well, what's 3,000 minus 450? We take our sample and we subtract from it those that had hearing loss. And we say 3,000 minus 450. That's going to be 2,550. And we know that's going to be greater than 10. Okay, then we have to look at for the other group as well. We say that from the 0506 group, 351, that's greater than 10. And then we have to subtract that from 1,800, and we have to say that that's greater than 10. So all of our conditions are satisfied. Boom, done, perfect. Now we can go ahead and look at the test that we want to do. So let's go to a calculator and see how we can figure that out. So most online calculators are going to behave the same way. It's going to have the same input. So let's go ahead and see how we can find it here. Again, on our calculator page, we go into our menu, and then we want to choose option number 6, stats, and then we choose number 7, this time stat tests, and we want to pay attention to which choice we want, and we know we're working with 2 proportions, so we choose a 2-prop z-test number 6 this time. Our number of successes, this is from our first group, and that was 450 out of 3,000 in our sample. And then our second group, we had 351 teens that showed hearing loss out of 1,800. And then we have to make sure we pick the appropriate alternate hypothesis. Well, remember that the first group that we had, that was the 88 to 94 group, and we said that was less than the 05 to 06 group. So we choose this. And here's all of our information. You can see that there's a lot here. So we write out our title, 2-prop z-test. We don't need to write out the alternate hypothesis because we already have that written down, but we do want to write out our z. We want to write out the p-value, and then we want to write out this p-hat because that's that pooled proportion that I was telling you guys about, that we at least want to make sure that it's there and present just in case anybody's looking for it. So now let's go back and write out all of our results here. So writing out the results of our test, we said that we did a 2-prop z-test. And with that, we had a z-score of -4.05. We had a pooled proportion p-hat sub c of 0.1669. And then we had a p-value that was extremely small, 0.000026. And we know that that p-value being so small, we know that's going to be less than any alpha that we would normally use. And the alpha we used was 0.05. So what does that mean? What do? We reject. We reject our null hypothesis, meaning we have convincing evidence that, yeah, the proportion of teens with hearing loss has increased. Remember, that's what we ultimately wanted to know. Did it increase? Well, our alternate hypothesis was that it indeed had increased, so we have to make some kind of statement that goes along with that. All right, so yeah, that was a lot. And guess what? We're still not done, because look, we need to answer part B. But the good thing is we've already done most of the legwork for part B. We've already written out all of our given information. We've already checked all of our conditions and all of that stuff. So here, when we're constructing and interpreting the 90% confidence interval, most of this is calculator work, okay? You can guess what kind of interval we're going to be creating. Since we did a 2-prop z-test, we're going to be making a 2-prop z interval. So let's go to our calculator and figure that out. So here from our calculator, we do the same thing. We go into our menu and we choose stats, but this time we're not going to go into stat test. We're going to go into number 6, confidence intervals, and then we're going to choose number 6, 2-prop z interval. Then we have to type in the same information that we had, our number of successes for the first group, and the sample of the first group. That was 450 and 3,000. And then we had 351 out of 1,800 say they had hearing loss for the 05 to 06 group. And this time we wanted to make a 90% confidence interval just to change things up a little bit. And here we get our results. Whole lot of stuff. Again, we want lower bound, upper bound. I think it's usually good to have your margin of error and your p-hat diff. That's your point estimate. Okay, so let's go ahead back to our notes and write that out. So from our 2 prop z int, we had a lower bound of negative 0.0637. It's okay that we have negative proportions, and you'll see why in just a little bit. Negative 0.0263 is our upper bound. And then we had a point estimate. That was the p-hat diff, and that was negative 0.045. And then we had a margin of error, and that margin of error was 0.0187. So that margin of error is actually positive, and that's interesting. So we can write out our interpretation sentence like such, that I am 90% confident that the interval from blank to blank, but again, our blanks in this case are from negative 0.0637 to negative 0.0263 captures what? The proportion. Well, what's our proportion that we're actually looking at? Again, we're looking at actually the difference in proportions of teens with hearing loss. The difference in proportions of teens with hearing loss. And then the question here, I'm obviously out of room to answer it in writing, but I'll verbally tell it to you here. So the question is this consistent with what you found in part A? Well, what do we see here? The interval is entirely negative. So is 0, a difference of nothing, a plausible value based on our confidence interval? And we would say no, right? Because 0 is not captured in the interval. So what does that actually tell us? Well, we know that the null hypothesis would then be false, because it's not plausible that those two proportions are identical. It's not plausible that the proportion of teens with hearing loss from 88 to 05 are the same. Now, what do we see? That they're both negative values. Well, if they're both negative, you have to think about when I'm subtracting two numbers, how do I get a negative number? I have to have small minus big, right? A small number minus a big number. That's how I get a negative number. Well, which one would be small? The small one would be P of 88, and the big one would be P of 05. And is that consistent with what we found? Yes, it's consistent with what we found because we have an entirely negative confidence interval. By having an entirely negative confidence interval, that means I have convincing evidence at the 90% confidence level that the true proportion, true difference in proportion is somewhere in the negative side, meaning that the 05-06 teens had a higher proportion of hearing loss than did the 88 to 94 teens. And that's it. All right, so we'll go ahead and take a look at the next one, this 2009 Form B question 4 free response question. All right, so this is a really dense problem. Go ahead and make sure you read through it. But we are looking at this French study that was completed during the 1990s that was comparing two different types of treatments for heart attack patients. So go ahead and read through and see what you can find. All right, so as you can see, I have marked my text, and there's a couple of things that I circled versus underlined. I circled that we have cardiopump and CPR, and what I noticed was that there was a treatment that was being applied to these heart attack victims. So this is important because it's an experiment, and that's going to tell us that we want to be emphasizing random assignment when we're checking all of our conditions, okay? Now, before I get started with anything, I want to read through what my instructions are. So here for step number 1 or part A, we want to check our conditions for inference, make sure that they're satisfied, state that they are, and indicate that they are satisfied. And then we're going to perform a statistical test to determine if the survival rate for patients treated with a cardiopump is significantly higher than the survival rate for patients treated with CPR. So what we want to know is the cardiopump greater than the CPR? That's my ultimate question. Now, what I'm going to do with this in the interest of time is I'm going to try and go through this very quickly. I'm going to have pop-ups on the screen for you to see what the actual steps are. but you can kind of walk through the process. If you can do this on your own, great, go for it, do it, check it out and see what I've got as a work through example. All right, let's get to it. All right. Did you get all that? I'm sure you did. Just try and rewind. I'm sorry, I know I was going fast, but I've got uploading limits, so I have to keep my time a little bit short if I can. But go ahead and make sure you take a look at this and try to understand what's going on. Look at the z-score. The z-score that we have in this 2-prop z-test was very high. We had a very low p-value, less than alpha. And when we have a p-value less than alpha, we know we have to reject that null hypothesis. And that null hypothesis was that there was no difference between cardiopump and the CPR, but indeed we did find there was a difference, and it was that our alternate hypothesis was true, that the cardiopump is a more effective treatment for these heart attack patients. We had convincing evidence that the cardiopump survival rate was indeed higher than CPR. All right, you guys, there are 2 other FRQs that I would like you to practice. I will post the keys for those later. Thank you for watching. Have a wonderful rest of your day.